Otherwise, you'd end up digesting away your mucosa. I mean, you're talking about a pH of 2 or so, which is why you need the Brunner's gland to neutralize that when the chyme makes its way out of the stomach. Down here, we've got predominantly what cell type?
Chief cell.
Chief cell. And what do they produce? Pepsinogen. And what else? Extrinsic factor, which if you don't have, you can't absorb vitamin B12, and it's a real bummer. All right? So pepsinogen, and pepsinogen is actually a proenzyme. All right? It's activated. The pro portion is cleaved off by acidic, the acid produced by parietal cells. All right? So if you see this tri-layered, tri-colored profile, and with a good eye, you can see that by eye on a white piece of paper. Just looking at your slide, you know you're talking about stomach. So I think, all right, this is an exquisite dissection where basically the lamina propria has been removed. All right? And you've got this one in particular. You don't see it, but you see the outside of the gastric pit. And you see how it bifurcates. Here we see only 2, right? This is the glandular region down here. Normally, as in what we're looking at here, these puppies are all coiled, so that when you slice the two-dimensional section through it, you get this profile here. All right? Okay, so looking at each of the regions in the corpus or body of the stomach closer, here you can see nicely, again, mucus crap adherent to the surface, but the duct coming down to about this region, and then we're talking gland. Here we can actually see, a tubular profile. You can see the lumen lined by what kind of cells? Parietal cells, right? Pink parietal. If we look further into the region, there's a classic parietal cell, probably chief paraparietal cells. Here, look at the capillary, right? And that would be in the lamina propria, surrounding these cells. Yeah, I think I've got. Okay, so the wrinkle then is the other regions. And if we talk about the cardiac region, the region where the esophagus joins the stomach, or the pyloric region, we no longer need, in the pyloric region particularly, to crank out any more pepsin or HCl. It's just mucus. Let's just move things on, all right? So you've got your gastric pits, and here the glands, based on staining properties, are secreting what? Mucus, exactly. You see the muscularis mucosa right there. And there's a reasonable lymphocyte infiltrating. What space would that be in? Lamina propria, the connective tissues. Oh, these might actually be out into the... Here's your classic gastroduodenal junction. Most of the slides I looked at today were all on the stomach side of it, all right? One slide, I think Linda's slide, was all on the duodenal side of it. And one slide I saw showed the whole thing. Again, if you're having trouble finding what you're supposed to find, refer to the histology image bank, because it's an image bank that illustrates the bold-faced terms in your lab manual. A lot of you are pulling that up simultaneously while you're looking at your scopes. Good idea, all right? If we look at this, we can see the gastric mucosa is relatively flat with invaginations, which are the pits or the ducts, right? We come down to the duodenal mucosa, we've got these finger-like evaginations. And again, look at the scale, the size of a villus compared to what you might want to hallucinate is a villus on the gastric side. Much bigger, all right? The other thing that you need to be squared away with is the difference between a surface mucus cell, and I'm talking morphology, what it looks like, and a goblet cell, all right? Surface mucus cell is a columnar cell, the apical, simple columnar, the apical 2/3 of which produces mucus. A goblet cell oftentimes are kind of rounded like that. They're in the small intestine interspersed among simple columnar absorptive cells which do stain well. When you get into the colon, the ratio shifts, so there are more goblet cells and fewer columnar absorptive cells. All right, one other thing. It's not that this intestine lacks invagination, all right? It actually has them, and you can see them here. We call those intestinal glands, or if you want to get fancy, crypts of Lieberkühn, all right? So you've got invaginations, which are the intestinal glands, and evaginations, which are the villi. So, if you look at a villus, you can see that it's lined by the absorptive epithelium, and it has a core of what? Lamina propria. If you're talking about an intestinal gland, it's surrounded by lamina propria, right? That's because it's sticking into the connective tissue space. What's this structure right here? All right, and it's cranking out what? Exactly. So to neutralize the acidic chyme that's coming here. What's that right there? Pyloric sphincter, which is derived from what part of the muscularis propria? Intercircular? Is that what I heard? Or you guys are... There's a mumble factor going on that I can't quite...
Isn't that 3 layers clustered together to form?
No. In the pyloric sphincter, it's the enlarged intercircular